So when you look at two different questions in cable selection, the questions can be worded differently. One can also have, for example, you might have the maximum demand and say, I've got 240 amps here. Now, when it talks about the maximum demand, what we need to then also do is build on top to get to the maximum cable size. So what we're going to do here, from here, we will work up to a maximum current, okay? And what happens there is we can then pick our size cable. The problem we've got to add is sometimes the cable might be, for example, maximum demand 240 amps, could be protected by a HRC fuse. So everything we need to do on this, we need to divide it, because as we divide, the current will go up. Does that make sense?
No. Dividing it makes it go up.
If I divide 240 by 0.9, what does it go up to?
256. Right.
Do you understand what I'm getting at?
Yeah, okay.
It'll go up in value.
Okay.
All right? If we come across to this one, on the other side, where I've had a cable size given to me, which could be 95 mil squared, say for example it equals 170 amps, right? Then we might take away things like the depth, it could be touching, the depth of it could be 0.9, this one could be touching, so there could be 3 cables and a HRC fuse. So what I have to do there is, as I multiply, right, it will go down in value.
Yeah, okay.
So what happens is when we've got the cable size in there, we look up the size of the cable, we then multiply and the value goes downwards. Does that make sense?
Yeah.
So then we come to a minimum size cable, so then we'll have a minimum size current. So I could have started off with 170. Time I've gone through and taken away all my deratings, which could be HRC fuse, touching and depth again, I could be down to 130 amps. That becomes my minimum current capacity. And you remember, when you've got things like HRC fuse, that has to heat up a wire, so we lose 10% on that because of 0.9. Depth of laying, we can lose because of heat in the ground or touching with cables. So all these deratings that we find do make a difference on the current capacity of the cable. When we get to maximum current, right, so maximum demand, you've done that and you worked out your mains, then you go, okay, it's protected by HRC fuses. So when I divide it, it could then go up to 250. Touching, all right, do that again, divide it, could come up to 265, and then depth, another one, another derating. And all these deratings too are like a 0.94 or something. They can go into, depth does go into 1.25 or something, but very rarely goes into a positive. But most of the time they're a negative, which is like a 0.94, 0.78, okay? Which at the end of the day is a percentage value of the full current of what you're doing. So this adds up, and then once we get to a maximum current of 265, then I can go and look for my cable size. Do you understand what I'm getting at? All right? So like I said to you, if the cable size is in the question, we need to multiply because things go downwards. Do you understand what I'm getting at? When we get a maximum demand, we have to divide because everything goes up. So I'll give you a scenario. I come to an old shop, right, and the guy's going to convert it into a pizza shop. He says to me, I've got an oven already in storage and it drags 220 amps. Then you have to look at the shop that's got insulation in the roof, so I'm going to have a derating for that. The fuses on the front board, a HRC fuse, I have to do with that. So it's gone from 220, it could go up to 240 or 250 amps. You then have to pick the cable to suit that load of 250 amps. Scenario B, I come along, the guy's got a shop, he's got a set of 35mm cables laying in the back in a J-box. He wants to hook up an oven to it, but he wants to know what's the maximum size oven I can buy. You then work out 35mm, it's running insulation, HRC fuses, I can only get 160 amps out of it. So that's the difference in picking a cable to a load. So here, we're picking the cable to match the load and the deratings. Here, we already have a cable, but we need to take things away to work out the minimum size current carrying capacity I can get out of the cable. Does that make sense? All right. When we look at cables in the AS 3008, we have you either have three-phase cable, which will be either three singles, right? Don't worry about the neutral. The neutral doesn't carry full current. All right? Only the three actives, red, white, blue. They'll either be three singles or a multi-core with three, and look at it, it's three core. Some questions say 4-core on Earth or 4-core, and people are looking for 4-core in the book. They don't talk about it. The tables 3.1 to 3.4 at the front of the book talk about, so let's go through those, open them up if you want. Table 3.1 talks about unenclosed. We all see that, yes or no?
Yeah.
Right?
Yeah.
These are a guide table, they're not a guide.
Page 29.
They're not going to tell you the answer, right? 3.1 to 3.4 only tell you how the tables work. All right? So, in other words, if it's directly buried in the ground, you look at table 3.3. If it's underground in wiring enclosure, that'll be 3.4. If it's enclosed, that's table 3.2. So let's go through them again. Unenclosed, table 3.1, table 3.2, enclosed. Enclosed doesn't mean just in conduit too, it means in insulation. All right? If it's clipped to a beam, that's partially surrounded. If it's fully enclosed, right, that means the cable's sitting inside the middle of the insulation. You've got to remember, insulation now doesn't form, it basically contains heat. Do you understand what I'm getting at? So that is partially, that means enclosed as well. The next one you got under that is buried direct in the ground. All right? You've either got two choices there. Three single cores or multi-core. Right?
2 single core, 3 single core.
That's exactly right.
Yeah.
So that's what I was kind of coming back to. Yes, we have active and neutral on a 2 single core, but neutral carries the same current as the active. But when we get to 3-phase, 3 single core or 3 core, the 3 actives carry the bulk of the current. If you look in the footnotes down the bottom, and they talk about the neutral carrying intermittent loads, which means is it's not carrying a full load current like the actives, then they don't look at it. All right? Now, if you look on your tables there, table 3.1 to 3.4, the tables work, there's an appendix B in the back. If you have a look at appendix B in the back, where we looked at voltage drop last week, that's a guide to where all the tables are. So if you look at the first one at the very top, right, the top one talks about temperature ratings. We all looked at that last week. The first column is the only one we're interested in. So if I got V90, it'll be 75. X90 will be 90 degrees. HLF 90. It's all the different ones that we get in the question. If we don't understand, we come to table 1. It's on page 14 there. All right? That covers us in the voltage drop tables and also in cable selection as well. The two differences between voltage drop and cable selection too, voltage drop doesn't take into account deratings at all. All right? It only talks about the length, current, and temperature. Cable selection covers pretty much all of that except for the length and all that stuff. We don't have to worry about that in cable selection. All we're worried about is depth of laying, temperature of the cable and all that. So we'll talk about those other tables just in a minute. So when you look at the tables 3.1 to 3.4, if you go down for the first tables between, I think it's table 4 through to 15, they all work in a sequence of 75, 90, 110. And they work their way all the way down to that table 15. 15 or 16, I think, is where they finish. So if you're looking at those, if you now look at, let's just look at table 3.1 for a start, and look at column 3. All right? You'll notice it, column 4. If you notice it there, and we'll go to item 1 in table 3.1, you'll see it says tables 4 and 5, and then columns 2 and 4, and then table 6. I just want to break that down. Table 4 is for 75 degrees, table 5 is for 90 degrees, and table 6 110. Now, when you look at the columns, it says columns 2 and 4, column 2 is for copper, column 4 is for aluminium. All right? So if you look at that and you've got a thing that says X90, I'm going to be looking at the second table in, not the first table, because that's 75 degrees. Does everybody understand what I'm saying? All right? The next thing you got is column 6. Column 6 has derating table. where it's got like 23, 22, 23 down the end there, they're the ones that you go to when you've got more than one cable. So if I have two cables and I have to work out touching or space between the cables, that is telling me what page to go to. Does that make sense? So for example, I got two cables in 3.1. I need to go to table 23. Is this making sense?
Yeah.
All right. Take column 5. Column 5 talks methods of insulation of cables. They're the notes. If it says to you, for example, clip to a ceiling joist, all right, or run inside partially surrounded, I would be looking in there for the comments on those there to help me relate to see if I'm in the right item number. Do you understand what I'm getting at? So if it says it's in open trunking, I'd go down and look for the word open trunking. So right down the very bottom near table 3.1, down at section 7, items 7 and 8, it's got the word in a ventilated trench or open trunking. You see what I'm saying? They're the things I need to look for in the question to help make sure I'm in the right area. Do you understand what I'm getting at? You get another one called closed trunking, open trunking, could be duct or closed. So you need to make sure you look at those comments. Partially, what did I talk about partially surrounded before? That was where the insulation is 3 sides around the cable because it could be clipped to a beam, and fully enclosed is where it's fully entrenched. What else can I tell you about these? All right, 3 single cores, like I said to you before, they all worked out in different areas. Some of the other things you've got to be careful of. Let's go to tables 25 and, tables 26, I think, 27. They are tables that are not mentioned in the front part of the book, and we need to highlight. So if you look at 27.1 and 27.2 for a start, you have 27.1 and 27.2. That's on page 88, all right? If we have a look at these two tables here, right, table 27.1, if we go to temperature of 40 degrees, all right, column 7, you'll see it's got a 1 in the whole column. Can we all see that?
Yeah.
Highlight that, because that's what we call a derating. Already done highlighted? All right, we'll just go back through it again. We've done 25 degrees, is that correct? Yes? And they apply on each table as well. So that means if you've got a 1, you don't have to do anything. It's the reason I tell you to highlight it, that if it's either side of that 1, you have to then apply that derating. Depth of lane, we all looked at that, 28.1 and 28.2.
Yep. Mm-hmm.
Those are there, 0.5 is your derating, same with the top there, 0.5. The only difference between these two is one's buried direct in the ground, the other one's got a wiring enclosure. The problem you've got with the buried direct in the ground, they actually have up to, it says up to 50, it talks about 50 million size of cable, not 50 amps. Do we all see that, yes or no? In column 2 there, it's got up to 50, and then above 50 to 300, that is talking cable size, not current. All right, I get some people thinking that's amps. The last one, table 29, talks about resistivity. Resistivity of the soil, all right, 1.2 is a common value that we see in the questions, which doesn't apply a derating at all. So that has a 1 factor across the top there. If it has a resistivity of 1.5 or 1, then we have to apply derating. Notice they're all, some of these ones in here are a 1 or could be a 1.04 and all that stuff. That's where it goes from like as I said, being below 1, it can become a positive part, all right? Those 5 tables I would mark because those ones do not have any reference at all from tables 3.1 to 3.4 at all. All right, you need to know where they are. Okay, so if the depth of laying is 0.7, table 3.1 to 3.4 will not tell you where that depth of laying table is. You need to know where it is. So appendix B in the back, you can mark that and highlight those 5 tables so that you know they relate back to as deratings. All right. So what we'll do, we'll go through one of the questions and see how we go. Main things you also need to identify as well in the question: copper, other conductors, copper or aluminium. Temperature, is it V90 or X90? Is it 90 degrees? Is it 3 core or 3 single core? Is the other thing I need to identify. What else do I need to identify? Are they buried direct in the ground? Are they touching a ceiling joist? All right. Sometimes the question says to you, touching in the ground, and then it says, the second part says, what would be the difference if I space them 450 or 200 mil apart. What would be the difference in current? Do you understand what I'm getting at? So you need to look at the question and read what are they actually looking for. Even if you want to draw a little picture, I get some guys that might draw, all right, this is touching, this is space, and they might put down 450 mil. It might sound stupid, but it takes the information from out of the question and puts it down below. All right. The first thing I always say, you also got to look at the question too. It works two types of questions work backwards. If you've got one with maximum demand too, and it says that the hotel's got example 400 amps, and it's going to drag 2 cables in parallel. What will be the size cable I need? What's the first thing that people don't do?
Don't divide.
Exactly, you don't divide the 200 amps by the 2 cables, or the 400 amps, whatever it was. They don't divide it by the number of cables. So they apply the full load maximum demand. It's like they were looking for, the full 400 amps, whatever it is, to look for that type size air, and then divide and build it all up, and then not really thinking, well, I had to cut that in half because I got half the current going through each cable.
So they don't realise that each cable is going to have 200 amps.
That's exactly right.
Yeah, right.
You're not looking for 400 amps on one cable, you're looking for the size of each cable. So if it's 3 cables, it's divided by 3, same thing. That's the most common mistake.
In the future, because
Sorry?
they'll get sacked in the future because they've overquoted.
No, you'd end up with a cable of like 150 square mil, and thinking, hang on a sec, what am I going to do with the other cable? So, anyway, so I think we'll go through a couple of questions. One of the questions there, so what I've just told you now, I want you to have a go at that first question. What page was that on, Mr. Jones? What page is that on that first question?
74.
74. So have a look at the first one and talk about what I just said, and then we'll go through it.